So E is when you get things continuously, when you're doing things forever. So let's start here. It is an irrational number. Tional. An irrational is basically a big fancy name for, hey, you can't write it as a fraction. It is a non-repeating decimal. It's an irrational number. And E equals roughly 2.718 dot. Just like pi is 3.141597 blah, 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 blah. E is a non-repeating decimal. Okay? And we'll say it's used when things happen continuously. C-O-N-T-I-O continuously, something like that. Spelled something along those lines. So use when you're doing something continuously. Okay. So your baseline equation is y equals e to the power of x. Okay. So first things first. This equation, do you think that would represent exponential growth, or do you think it'll be exponential decay? Do you know? Why do you think it's growth? Because it's bigger than 1. Exactly. So you're right. E is greater than 1, therefore this is growth. All right? And you're going to get a graph that looks kind of like this. This point is 0, 1. About over here, that's at 1, comma E, that 2.71 whatever. You still have a horizontal asymptote at y equals 0. Okay, and again, it's going to be there until you tell it. We'll tell you how we're going to change that later. But for the time being, it's at y equals 0, and you get a graph that looks like this. Is exponential growth. Cool. So whenever you're doing something continuously, that's when the E shows up. All right, kind of like whenever you're dealing with circles, that's when pi shows up. Pi. All right. Anyways, I know the jokes are horrible. Get over it. So let's scroll down a little bit. Natural base functions. All right, all this right here boils down to what's the difference between growth and decay? You can have decay with an E value. Okay, so like this one on the left, that's growth. You're used to it going up like that. All right, so that is your y equals e to the x. Okay, the one to the right is your decay function. That would be y equals e to the negative x. Okay, so there are actually two ways to get a decay function. They really are the same thing, but what is it about a negative exponent that would mess with that base? You remember? What does a negative exponent do? It flips the fraction. So e to the negative 1 is really 1 over e, right? Which that's 1 over 2.718 dot, 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 dot. Is this number less than 1?
No.
1 divided by 2. Just take the 2. Is that less than 1? Yes. It's like 2.7, that's like 1.6 something. Like 0.6 something. So yeah, because we made that exponent negative, it flipped this fraction and made your base a decimal. Okay? So there are two ways to get a decay function. The first is to have a less than 1 base. The second way is to make an exponent negative. That's the second way to do it, which in reality is kind of the same thing. I will say this. What happens if you have a decimal base and a negative exponent? Do you think it's growth or decay? If you have both of them, what do you think? Any guesses?
Growth.
It's growth. Because it flips them back. It's kind of like a negative times a negative is a positive. It's the same idea. Well, the decimal flipped over back into a whole number or a greater than 1, it just turns it back into a growth function.
So if both are negative, it's going to be growth?
Well, here's my point. If you have 1/2 to the negative x, that is actually a growth function. Yes, this is less than 1, so you think decay. Yes, this is a negative, so you think they're decay.
Oh.
But this flips that 1/2 back to a 2. So it's really a growth function. You follow me? So am I going to give you one of these? No. It's just a little bit more, just kind of digging in a little bit deeper. If I confuse the mess out of you there, I apologize. Just ignore it and go on with life. Okay? But that's what that is. All right, let's turn the page. So first things first, let's talk about how do we deal with the E in general. First things first, we're going to say treat E as a variable. V-A-R-I-A, a variable. Okay? Treat it just like any other x. It is not a variable, it's a constant, but anything you can do to x, you can also do to E. Okay, so like letter A, if I am multiplying your bases, what do you do to those exponents? You add them. So that's e to the 3 plus 6. Well, what's 3 plus 6? 9. Cool? That's what that is. That's what that simplifies down to. All right, now, do you have to write this portion right here?
No.
No, you don't. I would write it in your notes, just so if you come back 6 weeks from now and go, what did I do there? Oh, yes. It makes more sense. But on general homework, no. All right, so letter B, same idea. Let's reduce that. What's 16 over 4 reduced down to? 4. Okay. When you're dividing your bases, you divided your e's, what do you do to the exponents? Subtract. So it's top minus the bottom, 5 minus 4. What's 5 minus 4? 1. So e to the 4e. Cool. All right, letter C. If I have an exponent to an exponent, what do you do? That's if you're multiplying your bases. But if I have an exponent to another exponent, you multiply them. So 2 times 4 is what? Negative what? Negative 8x. Now question, I forgot something there. Very common omission. What did we do? We didn't give it to the 3. Remember, there's a 1 right there. So it's a 1 times 2, which is a 2. What's 3 squared? 9. So it's really 9e to the negative 8x. Okay? That's, again, a very common thing to be forgotten. Okay? Any questions on that?
Why do you get 9?
Where did I get 9? What is, you understand where I got the 2 from?
Yeah.
What's 3 squared?
Oh.
All right, take 15 seconds, do the next 3. Take 15 seconds, do the next 3. Cool. Sure. All right, any questions on how we got this going?
You get 1,000.
Huh?
You get 1,000.
How do you get 10 to the third power is 1,000? Basically, what the, if, you know, your 10s to the third, well, this just made 3 zeros, 3 zeros. If it was 100 to the third power, like if it's 100 to the third, well, that's 3 sets of 2 zeros. So that's 1, 2, 3. So it'd be 1 million. You follow me? That's just the easy way to do like hundreds and stuff like that. Cool. All right. Any questions at all? Anything else?
No.
All right, let's keep rolling. Let's talk about graphing these real quick. Tell whether each function represents growth or exponential growth or exponential decay. So letter A, what is that? Growth or decay?
Growth.
Why is it growth? Because the base is bigger than 1, you're right, but there's the other reason we talked about. Because the exponent is positive. Okay, good. So we're going to say growth because exponent is positive. I'll write it out positive. Okay? And so let's parse this out a little bit. All right, you still got your A value and your B value. See if you remember, what is your A value in this case?
3.
3. That's what's being multiplied. What is your B value in this case? What's your base? What is raised to the power of x? The e. All right? It's e to the x, so that's your base. If it was 4 to the x, 4 would be your base. Okay? So that's still your base.
So,
All right, so let's start graphing this. Pull out a calculator. Let's knock this puppy out. Y equals. All right, now you can go to one of 2 places for this. There is, come on. There is an E right here above the divide sign. There's an E right here above the divide sign. There's also an E right here above the ln. The e to the x is down here beneath the ln. So I'm going to go 3 second ln for that to the x. Cool. Go 3 e to the x. Again, e is down here by the ln. That's probably the one you'll use most. But it's also over here over the divide. But this one doesn't have an exponent. That's the only difference. All right, and then go to the table. So table. All right, and you'll notice over here, you've got all these, like they're practically 0. So we're not going to worry about this. I'm going to start with the -1 and go on. So I got -1, 1.1. I got 0, 3. Remember, your A value is your y-intercept. Your A value is 3. So 0, 3. You got 1, 8.1, and then number 2 is off the graph, so I'm not going to worry about 2 and beyond. Okay? So I'm not going to worry about the ones that are all practically 0, but I'm going to start at the -1 and move on. Okay? So here we go. Back to this. So I got -1, 1.1. 0 was 3, and 1 was 8.2, I think? 8.1, I think it's, yeah. Yeah, 8.2 is 8.15 or something like that. And then 2, if you want to write it down, it was like 22 or something like that?
22.2.
2, okay. So that's off the graph, obviously. But my point is, plot whatever you can put down, okay? Which sometimes is a good bit, but then don't buy the rest. So I've got 1.1. I got 3, which again, that's your A value, is still your y-intercept. And then 8.2, that's 10, 9, 8.2. We'll just say it's right there. Cool. Before we draw the actual line, we need to, what else do we need to put out? It's that fence. Starts with your asymptote, your horizontal asymptote. And your HA is at y equals what? 0. Good. So when we actually go to graph this, let's get green. I like green. It's not easy being green. So that's your graph of 3e to the x. Cool? And again, if you don't have a graphing calculator, on the very front of your notes, there's a thing that says link to a graphing calculator. That'll work for you. Or if you have an Android device, you can get a free one on your phone. All right, letter B. Any questions about letter A? Anything you want to talk about? Sweet, letter B. Let's keep moving. First things first with letter B. Is that growth or decay?
Decay.
Why? Negative exponent. Very good. So let's say it's decay. Decay because exponent is negative. All right, zoom out just a little bit. All right, so your A value, what is your A value in this case? 1, good, it's times 1 out front. What is your B value?
E.
Good. All right, so from here, let's get some points. Cool. So go about it over to your calculator. All right, I know you're watching me put it in, but I kind of want you to do it too because I want to make sure that it's not hard to put in, but make sure you know how to do it. You follow me on that? So we've got second e to the x. What is it? Negative 0.5x. Just like that. And we'll go to our table. Which you'll notice down here it's trailing off to 0. As x gets bigger and bigger, your y's are trailing off towards 0. So we'll stop at the 0.6 right here. And on these ones, we'll just pick up everything you can put on the graph. So negative 4 and beyond. So we'll pick up these 6 points. Okay? All right, and I got them written down over here so I don't have to memorize them anymore. So that was negative, if you want to, I keep forgetting that. Negative 5, 12.1. Negative 4 was 7.3. Negative 3 was 4.5. Negative 2 was 2.7. Negative 1 was 1.6. 0 is 1.6. Oh, it's 1. 0 is 1. I looked at the wrong one. 0 is still 1 because that's your A value. I was like, that's not right. And then 1 was 0.6, and it just kind of gets incrementally closer to 0. Okay? So we got 5, 7, 4, 7, okay, 1, 2, 3, 4, 9, 8, 7. So about there. 3 is 4.5, 1, 2, 3, 4.5. 2 is 2.7, about there. Close enough. Negative 1, 1.6. About there. 1.6. About there. Cool. Before we draw the line, what else we got to put on there? Your asymptote. Your asymptote. So your horizontal asymptote in this case is where? Y equals 0. Good. And we'll go. And that's your graph. Cool. Any questions, comments, complaints? Agent, that's horizontal asymptote. Yeah, it's a lot of letters, so I'd spell it out. All right? Any questions? It's basically, it's going to be y equals 0 until we give you stuff like this, like y equals e to the x plus 4. Because that plus 4 shifts everything which direction? Up 4. So if I shift it up 4, your horizontal asymptote's going to be at y equals, what do you think? 4. Exactly. All right. So, but for the time being, just remember it's at 0. Okay, it's always at 0. But when we start shifting things around, that's when it's going to change on us. Okay, which I don't think we do it until at least 7.4, if not 7.5. But whatever. All right, turn the page. Let's keep rolling. All right. Compounded interest, continuously compounded interest. Okay, so last week we gave you this one. A equals P. 1 plus r over n to the power of nt. Okay? When we said things were compounded monthly, weekly, daily, hourly, whatever, semi-annually. All right, when we are compounding things constantly, all right, we're not stopping, we use this formula. A equals P e to the rt. Okay? All this big stuff in the parentheses kind of boil, the ends go away, and it all boils down to an e to the r. Okay? Which is what it boils down to. And your variables are the same thing. A, do you remember, was A your starting point or your ending point?
Ending.
Ending point. Good.
Oh,
P is your starting point. P stands for principal. And to an accountant, principal is however much you're putting up in the beginning. Whether that be how much money you're putting there, how much assets you're putting in there, whatever. So P is your start. A is your end. What do you think T stands for? Time. What do you think R stands for? Rate. Not vate, rate. Okay? No, I don't say vate. I said vate. Whatever. Here we go. So that's that. So with these type of questions, it's all going to be, hey, plug in what you know or what you don't and solve for what you don't. That sort of thing. Just like the other ones. They're plug and chug type problems. So here we go. Your friend, you and your friend each have accounts that earn annual interest compounded continuously. So it's continuous. Are we going to use the equation with the n in it? Or are we going to use the one with the e in it? The e. If you see continuous, go for the e. All right? So yours can be modeled by the account. Here, let me zoom in a little bit. Yours can be modeled by the account, by the equation, blah. Okay? The graph shows the balance of your friend's account over time. So the graph is your friend's, you're the equation. Which account has a greater principal? Okay, so principal. So your principal. How much is your principal? How much are you starting off with? What's up? 4,500. That's your p-value. Remember, it's P-E-R-T, so that's your starting point. So you're starting with $4,500, 4,500. Okay, what about your friend? How much is your friend starting off with? Go down to the graph. Where's your friend starting?
4,000.
4,000. That's his y-intercept. That is his starting point. So who's starting with more, you or your friend? You! You start with more. Why? Why? Yeah, why? You would think I never got through kindergarten with the way I write. All right. All right, the other one, it says, which has the greatest balance after 10 years? Okay, so let's find your balance after 10 years. How do you find, what would you do if you knew you were looking for 10 years down the road? Well, not times 10. Yeah, your t value, right? Your time is 10. So we'll plug in 10 right there. So write it out. So for you, A equals, your principal is 4,500. E to the 0.04 times 10. Cool? Just stick it in the calculator. Take a calculator, see what you get. I think it's like 6,700 and something, but I don't remember off the top of my head. 6,713 points. Is it 21 or just 2? 02?
What do you plug for E?
I think it's 21. All right, what did I plug in for E? We went, so I can quit. We went 4,500. Second E right here. Second E to the 0.04 times 10. And you got 6,713.21. Cool. All right, so, okay, so that's you. What about your friend? How much is your friend at 14 years? So we'll say your friend at A of 10 years, I'm sorry. So how are you going to find that from the graph? Please say that for me. You go where at 10? Your x coordinate or your y side? Your x. Your horizontal axis is your years, so go to 10 years and right there. What is that roughly? Is it halfway or is it less than halfway? Less than, so we'll say 7,400, 7,400. It's a good enough guesstimate, okay? You can't do perfect. So your friend at A of 10 is 7,400. Who has more money at 10 years? Him. F has more moolah at 10 years. Cool.
Flash.
I told you that was different. This is difficult. All right, letter B is the exact same question with the different stuff. All right, but we're just plugging things in the equation or we're reading the graph, however you want to do that. All right, but any questions on this at all? All right, turn the page.
Wait.
Whenever you're done writing, turn the page. Yeah. All right. We're actually almost done. Letter C, you deposit $4,250 to an account that earns 5% interest compounded continuously. Okay, it says compounded continuously. Do we want the equation with the E or do we want the equation with the N? The E. Worst case scenario, you say, hey, we're talking about the one with the E, so it's probably the one he wants. All right. Compare the balance after 10 years with the account on the graph on the previous page. Okay, whatever. Here we go. So A, P, R. Do we need an N value? Nope, don't need it. T. All right, 4250, is that your starting amount or your ending amount? Starting, that's what you're depositing. So that is your starting principal. Your rate, what is your rate? Not 0.5, 0.05. Remember, move it twice. Think of it this way. If your percentage is in ones, you follow me? If you have like 1 through 9, you got to put a 0 in front of it. If it's 10 or above, you don't.
What do we cross out N?
Huh?
What do we cross out N?
Do you, for your equation is A equals P E to the RT. So do we need the N for this one? No. All right, what are we using for time? 10. So take, I don't know, take 5 seconds. Write your equation.
Oh, you're in C, I think.
Oh, we're on C, I'm sorry. Take 10 seconds, write your equation. All right, what did you write?
4,250, or E equals 4,250, parentheses, 0.50,
It's just E to the power of the rate times time. You don't need parentheses at all, other than like the times 10, unless you want to put a dot there, that's fine. I just like putting parentheses because I may think the dot is a decimal versus times. If you haven't noticed, my handwriting is, oh, I'm sorry, beautiful. I should be a calligrapher. All right, anyways, so here we go. Shove in your calculator. If you got all that, A equals, what is 4250 times E to the 0.05 times 10? What's up?
7007407.
Anybody else get that? Cool, I got 2. I got 3. Sweet, we'll say that's right. I have a hard time believing 3 people put it in wrong together. So that's how much money you have. Compared to the one on the graph, we said it was like 7,400, so your friend still has more money. But whatever, that's what you got. All right, the last questions. The last questions are easier than you think. All right, it says use the properties of exponents to rewrite the function in the form y equals a 1 plus or minus r to the t, which if you remember, we used this when we were saying, hey, percent increase or percent decrease. We're trying to figure out what does this do to the overall percent increase or decrease, okay? So here's what I'm going with this. Yes, your rate is 0.025, so that's 2.5%. But because you are compounding continuously, that's not quite what your rate actually is, all right? You might be quoted 2.5, but because of the way it's compounded, that's not quite right. It's okay, and no one's going to blame it. It's not illegal or anything to say that, but that's not what's actually happening. All right? So here we go. What they want us to do is turn it into this. It's actually pretty easy. Just follow me along. So we got y equals, first thing we got to do is we got to break that apart. So I'm going to put in parentheses e to negative 0.025, close parentheses, and raise it to the t. Because remember, an exponent to an exponent, you multiply, right? So if I were to put those back together, I'd go back to this. I just put it backwards. Okay? From here, let's just crunch those numbers in the middle. e to the negative 0.025 comes out to be, what is it? Somebody take it in your calculator. Tell me what it is. 0.9 something. 0.975. Give me one more decimal. Cool. Because the difference is going to be minute. It's going to be a small difference. So we're going to go all the way to 4 decimals, and we'll keep that t out there. Cool still? All right, the last thing we're going to do, we're going to break it out to that 1 plus or minus. So here's what I want you to do. 1, and then subtract that. What is 1 minus 0.9753? Do 1 minus that 0.9753. What do you get? 0.025247? 0.0, sorry, not 2. 0.247. Now question. Do you think it would be 1 plus this to get to 0.9 or 1 minus that to get to 0.9? Minus. All right. I did 1 minus the 0.9 just to see what that difference was. Okay? And then you got to know whether you should add it or subtract it to get back. Okay? So, does this now look like that? Yes. So what is your rate? Give me a second, Henry. So what's your rate in this case? 0. What? 0.247. So move your decimal. You have a 2.47% increase or decrease? Decrease. So remember how we said the equation uses 2.5, but because of the E, it actually went down just a little bit. Okay, that was the actual interest rate that's actually happened. Henry, what'd you ask?
How did you get the second part after?
This?
Yeah. How?
I just shoved that in the calculator. E to the negative 0.025.
After that.
This?
Yeah.
Well, because we got to get it to a 1 plus or minus, I just did 1 minus this to find the difference. Does that make sense? Like 1 minus 0.94753
How
gave me
do
that.
you know if it's minus or plus?
Well, let me ask you that. Is 0.9 less than 1 or greater than 1?
Less.
So do you think it was 1 minus something or 1 plus something? Minus. Okay. We're just going to do one more because you notice how most of the time when we give you something, we kind of give you steps, but it's different every single time. This is one of those, it is the same thing every single time. It does not change. Okay? The only difference in this case is you got that 1/3 out front. Yeah. Which you can ignore it. So we're going to go, you can ignore it because it just kind of comes down the line. So y equals 1/3. What are we going to put in parentheses? Look at letter A. What are you going to put in parentheses? Good. What are we putting outside? T. Excellent. What did we do next?
Put in the calculator.
Put what in the calculator? E to the 0.3. Good. So shove e to the 0.3 in the calculator. And tell me what you got. Give me 4 decimal places. 1.349. What? 8. Okay. 1.99. Okay. Cool. We'll go with it. All right. Where did we go from there? What did we do next? Yeah, we did the whole 1 thing. So this one is actually a lot easier than the last one. If I did 1, do you think we're going to do 1 plus or 1 minus to get up to this?
1 plus.
1 plus. What do you think you're going to be adding? You can just look at it. 0.3499. Because it's 1.3499, right? So it's 1 plus 0.3499.
What the heck? Why you drop the 1?
Remember, we're breaking it up to look like this. A 1 plus or minus our rate. So we want this number right there to look like 1 plus or minus something. Cool? So this is, you can literally say this one is even easier because it's 1 plus that. It really is that simple. Okay? There we go. So your rate in this case is what? Your R is 0.3499. So when you move your decimal point twice, what's your percentage? 34.99%. Which is actually drastically different from that. If I move the decimal point twice, that is 30%. All right, so when I do that continuously, I actually get 34.99. All right? You're either getting that interest back or you're being charged that interest, one or the other. Cool? All right. We're calling it.